Hello and welcome back. For this video, we're going to talk about systems of inequalities. You can see the only goal we have here is solve systems of linear inequalities by graphing. As it turns out, that's pretty much the only way you can solve these systems without a lot of guess and check. For our first system, we have what appears to be a standard form and a slope-intercept form. On this top one, I'm going to solve for the y-intercept, and that's going to be the -6, which is here, divided by the -2. So the y-intercept will be +3. So -6 over -2 is +3. So that one starts at 1, 2, 3. It would be right here. And the slope of this line is going to be the opposite of the one out in front. So the opposite, that would be -1 over the b value here, which is -2. So I get a slope that is equal to 1/2. So I'm going to go up 1 and over 2. And I'm going to do this a couple of times. I'm going to reverse the order here too, so I can create a more accurate graph. So I'm going down and to the left, down 1, left 2. And because the inequality here is not equal to, I will have a dashed line in the middle of my graph. It will look something like that. Now the shading, so in order to solve this, I'm going to go and do the traditional way, which is pick the ordered pair 0, 0, which is the origin. Put a 0 here and a 0 here, and I evaluate that out. And I get 0 is greater than -6, which is a true statement, which means the solutions are found on the same side as that point I selected. So the solutions for this graph are all found on this side of the line. When I go to my next one, I have a y-intercept down here, b value of 0, which means it goes to the origin, so I'm going to use red here. And the slope is right here, it's 3 over 1, so 1, 2, 3 over 1, 1, 2, 3 over 1. I'm going to do that a couple times up, and 1, 2, 3, a couple times down and to the left. Again, I'm still going to do a dashed line here. So dashed line along this one. And because this one's already in slope-intercept form, we can use the shortcut just by looking at the y value here. We're looking for the y values that are smaller than the y-intercept. So y is less than 3. So less than 3 would be all the values that are down here. So I'm looking for the shading that goes on this side. And the solution to the system is simply the region where the two parts overlap. So all this region right here is part of the solution. And you want to keep in mind that since both dotted lines are dashed, there are no points on the boundary lines themselves that are part of the solution. So everything's got to be out in that yellow area. All right, for our next one, we have another system. The top one appears to be in slope-intercept, so I'm going to use the y-intercept, which is 2 right here, and the slope is going to be 1/3, so up 1 and over 3, and do that a couple of times across the graph, and I'm going to reverse it. Then I've got a dashed line because the inequality is not equal to, and I can use the special technique here. Since y is greater than the 2, I'm looking for points that are above my y-intercept, which is here in the middle. So all my solutions for that inequality are going to be here. Now the traditional way is still to select 0, 0 and check to see if it's true or false. When we put that in there, you'll see that 2 is less than 0, which is a false statement. That's why we're graphing above the line. This one down here is simply a vertical line at -3. So -3 is here, and because it's a solid line, or an equal to, I have a solid line, solid vertical line. So I'm going to draw a vertical line this way. And I am looking for x's that are bigger than -3, and that would be to the right of this line. So all those solutions are over here. But the solution to the system is only where the things overlap. So all of this region right in here is going to be part of the solution. And something you want to pay close attention to is this part of the line, because it's solid, is part of the solution. But this part of the line is not part of the solution because it's dashed. And the point where they cross right down here is also not part of the solution because it contains a dashed line. So any point up in this region here is a solution to the system. Okay, they want us to solve again by graphing, but they're telling us that there's not going to be any solution. Let's take a look and see what that looks like. Okay, so the y-intercept of this first one here is going to be the b value over the c value, which is 0, so it crosses through the origin. And the slope here is going to be the opposite of a over b. So I have a 3/4 slope. So 1, 2, 3, 1, 2, 3, 4. I'm going to try that again. And then reverse it. And then draw my dashed line here because it is not equal to. And the shading, if I go back to this problem, I can't choose 0, 0, but I can take a look at this relationship. Right now, y is greater than that intercept of 0. The only question is, will it stay greater than when I put it in slope-intercept form? If we look at the positive out in front of the 4, the answer to that is yes, so it will stay greater than. So I'm going to shade above my line, or above the y-intercept. When I come down to the second one here, the y-intercept is going to be 8 over negative 4, which is going to give me a negative 2. And the slope is going to be the opposite of negative 3, which is negative 3 over the b value of negative 4. So I have a slope of positive 3/4. So up 1, 2, 3, 1, 2, 3, 4. Then I'm going to go down on the left. And this one's going to be a solid line because of the equal to. And then when I go to figure out the shading, again right here I look at this. And right now y is less than, which means shading below the intercept of negative 2. However, but because of the positive or the negative right out here in front of the 4, that inequality will eventually flip if I were to write it in slope-intercept form. So my y will end up being greater than or equal to, so I'm going to shade above. So this particular problem does not have no solution. It still has a solution. However, the solution only begins right here at the blue line and then going up into this region. So I think there may have been a mistake in the book. If that inequality was facing the other direction, then I would have shaded below the red line, and then there would not have been any overlap, meaning there would be no solution. But this one does have a solution, starting at the blue line and then going up. Okay, for our last example, they want us to apply systems of inequalities. Family and consumer science classes making pillow and blankets to donate to local shelter. The class has 40 yards of fabric to use, and pillows require 1.25 yards of fabric and take 1 hour to make. Blankets use 4 yards of fabric and take 2.5 hours to make. The class has 28 hours of class time left for the semester, and they want us to determine the number of pillows and blankets the class can make for the shelter. Then, of course, they want us to find a viable solution. So since they're asking for how many pillows and blankets, I'm going to define P as equaling number of pillows that they can make, and B equals number of blankets they can make. Now they have 40 yards of fabric, so the amount of fabric used by P pillows and B blankets must be less than or equal to 40. Okay, so we've got 1.2 yards of fabric for a pillow. So 1.2 times the number of pillows, that's how much fabric is used by a pillow. If I add to it how much fabric is used by a blanket, which is 4 yards, so 4B, that's got to be less than or equal to the amount of fabric they have, which is 40. So your total fabric's got to be less than or equal to 40. And we also know that they have 28 hours left of class, and we also know how long it takes to make each one. So it takes 1 hour to make a pillow, so that's 1 times P, plus the amount of time it takes to make a blanket, which is 2.5, so that would be 2.5 times the number of blankets. And they have to be done in the next 28 hours, so it's got to be less than or equal to 28. So there's our system. All we got to do is graph it now. Okay, so here in Desmos, I have the two equations, or two inequalities. And if I turn the first one on, you can see that's what the first one looks like. I had to zoom out a little bit because my intercepts are way out here, 32 and 10. And the second one, which is the number of hours, looks like this. And when I turn them both on together, we get a picture that looks like that. Let me maximize this. Now the solution, or a viable answer, a viable solution they're looking for, is anything that falls within this region right here. But keeping in mind that negative values of y don't make sense, negative values of x don't make sense, and also we're only interested in how many whole pillow and how many whole blankets we can make. So we're only looking for answers that fit on the crosshairs here, which give us integer solutions. Remember, up here we can make 10 there and we can make 28 there, but that's without making one or the other. Now, one thing I did do is on my x-axis, that was my pillow, so x equaled p here, and my y-axis, y was equaling to the blanket, so y equaled b there. So any solution in there works. Let's say I choose 12 and I could make up to 5 here. So I could choose 12 pillows and 5 blankets in the same amount of fabric or the same amount of time, either one, because this covers both of those scenarios.